Hi, Year 11. We're going to take a look at AQA Topic 3, Quantitative Chemistry. We're going to do some revision. I've got some questions here that we're going to go through. You'll need a calculator, obviously pen, paper, but definitely a calculator, and pause the video when you feel you need to. So let's start with this. So question 1, we're looking at individual atoms have a tiny mass. As you know, the mass of an atom is concentrated around the nucleus, which contains the protons and neutrons. The first two questions are worth 1 mark each. So you can see lithium and you can see fluorine. The first question is lithium has a relative atomic mass of, so it's either 7, 3 or 4. And the next question is fluorine has a relative atomic mass of 19, 9 or 10. Pause the video here and have a go, please. Okay, what you should have found was the answer to lithium is, the answer to lithium is 7, because that's made up of 3 protons and 4 neutrons. And the answer to fluorine is 19, and that's made up of 9 protons and 10 neutrons. So that's straightforward, 2 marks. If we move on now, the next part of this is where you need to work out the relative formula mass, or some textbooks call it relative molecular mass. And what you will need is the table here, which gives you the atomic mass of hydrogen 1, oxygen 16, carbon 12, and you can see the rest and so on. So pause the video here, have a go at the relative atomic mass of relative formula mass, calculate the relative formula mass of water, carbon dioxide, butane, and magnesium nitrate. And what this question does provide you with is the formula for each compound. Pay particular attention to magnesium nitrate because it's got some brackets there. So pause the video and off you go. Okay, let's have a look. So water, H2O, which means 2 hydrogen atoms, which are 2 times 1, plus 1 oxygen atom, 1 times 16, so that's 2 plus 16. The answer was 18. Next one, carbon dioxide. You can see there's 1 carbon atom, 2 oxygen atoms, and the answer was 44. Next one, butane, C4H10, 4 carbon atoms, 10 hydrogen atoms, so the answer was 58. The third one, magnesium nitrate, the final one, magnesium nitrate. The brackets are there, so everything inside the brackets, 1 nitrogen atom, 3 oxygen atoms, you need to multiply by 2, and you've got 1 magnesium atom, so the answer there was 148. That's worth 4 marks. Okay, moving on. Now we're going to work out the number of moles. To work out the number of moles, you'll definitely need to know the formula masses, or molecular masses, as some textbooks call it, these numbers. So the first one, how many moles are there in 100 grams of water? Now you've already worked out the molecular mass of water. Next one, how many moles are there in 2 kilograms of carbon dioxide? Again, you've worked out the mass of carbon dioxide, which is 44. Don't forget to convert the 2 kilograms to grams. And the final one is what is the mass of 20 moles of butane. So pause the video here and off you go. Okay, here we go then. Each one will be worth 2 marks. So the first one, how many moles are there in 100 grams of water? Well, 1 mole of water is 18 grams. You've got 100, so it's 100 divided by 18, and that comes to 5.56 moles. The next one, carbon dioxide. Well, you've got 2 kilograms, which is 2,000 grams, divided by the mass of 1 carbon dioxide, which is 44, and you get 45.45 moles. And the third one, butane, you've already worked out the mass of butane is 58 for 1 mole, but you have 20 moles. So 20 times 58, and it's 1160 grams. And there you go. And each one is worth 2 marks. If we move on, the next one, this is a reaction between iron oxide and carbon monoxide. So this is a blast furnace, and the product is molten iron and carbon dioxide. And for 2 marks, the first question, you need to balance the equation. So pause the video here and balance it, please. Okay, what you should have is, if I try and do this as small as possible, so you've got Fe2O3 reacting with 3 moles of carbon monoxide to produce 2 moles of molten iron and 3 moles of carbon dioxide. That's what you should have got. It's worth 2 marks, this one. So the next question is talking about if 32 kilograms of iron oxide was heated in excess carbon monoxide, what would the mass of iron be produced? It's worth 3 marks, this one. So looking at the equation, you are interested in this and this only. So working out the relative formula mass of iron oxide, that should come to 160 grams. And what you do get is 2 moles of iron, which is 2 times 56, which is 112 grams. But the question is talking about 32 kilograms, which is 32,000 grams, and it's saying how much of that is produced. So the answer there, you can work out, should be 22,400 grams. Okay. Now, I don't know how you do this in maths, but that's times 200. So you have to times that by 200 also to get that answer. And that's worth 3 marks. If we move on, a graph question. And what you should have, for 2 marks, use Stephen's results to sketch a graph of these results, and don't forget to label the axes, and there should be a diagonal line from the left to the top right. As long as you get that, you get your 2 marks. And to balance this equation, complete the balanced symbol equation for this reaction. Pause the video here and have a go at this. Okay, so what you have got, you've got magnesium reacting with 2 moles of hydrochloric acid to produce hydrogen gas and magnesium chloride. Now, it then talks about, and that's worth 3 marks, by the way, the other product in the reaction is magnesium chloride. When dissolved in water at 30 degrees Celsius, it has a solubility of 36 kilograms for every 100 litres of water. Calculate the maximum volume of water in litres again at 30 degrees to dissolve 72,000 grams. It's worth 3 marks, so pause the video here and let's see if you can get the answer. Okay, so let's have a look at this. So what it's saying is 36 kilograms is 36,000 grams, and that's in 100 litres of water. But the question's saying, what about 72,000? What volume of water would you need? Well, it would have to be twice as amount. So the answer was 200 litres. That's been worth 2 marks. Okay. Moving on. Calculate the percentage by mass of magnesium in magnesium chloride. So we're 3 marks, and he wanted to 3 significant figures. So I hope you've done that in maths. Pause your video here and have a go, please. Okay, so the first thing to do here is you need to work out the relative formula mass of magnesium chloride. And if you do that, you'll find that it's 95. 1 atom of magnesium, 2 chlorines, that's 35.5 times 2, which is 71. Magnesium is 24, total 95. So the percentage by mass is, out of this, 1 atom of magnesium is 24. So it's 24 divided by a total of 95. And because it's a percentage, times by 100, and you're going to get 25.3 to 3 significant figures. Okay. Next one. Explain why, when dissolved in water, the magnesium chloride conducts electricity, but it doesn't when solid. So pause your video here and have a go at this, please. Okay, let's have a look at this. So, what are they looking for? So, in a solid, the ions are fixed and cannot move. That should get you a mark. When you dissolve the magnesium chloride, the ions are now free to move. And I suppose the third thing you need to put down is ions are charged particles. Okay, moving on. Question 4. In a reaction between magnesium and sulfuric acid, 5 moles of magnesium react with 7 moles of sulfuric acid. Write a balanced symbol equation with 3 marks. So pause the video and off you go. Okay, so what you should get here is magnesium reaction with sulfuric acid, and that makes magnesium sulfate and hydrogen gas, and it's fully balanced. And what you should see is 1 mole to 1 mole to 1 mole to 1 mole. So looking at the next question, one of these reactions is in excess. Calculate the moles of products formed, showing all you're working out. Well, in the question, I'm using 5 moles of magnesium. Now looking at this, because it's 1 to 1 to 1 to 1, if I use 5 moles of this, then I'm also going to get 5 moles of magnesium sulfate and 5 moles of hydrogen. So when it says calculate the moles of products formed, well, the answer is 5 moles of magnesium sulfate and 5 moles of hydrogen. And the next one, identify the limiting reactant. Well, the limiting reactant is obviously sulfuric acid, and we only need 5 moles but in the experiment we have used 7. So 2 moles are unused. Question 5. Look at the balanced symbol equation for the reaction between potassium hydroxide and nitric acid, and it's balanced. A student wants to make up 25 centimeter cube of solution of potassium hydroxide with a concentration of 0.1 moles per litre. So what mass of potassium hydroxide will the student need to use? Worth 5 marks. So pause your video here and have a go. Okay, so let's have a look. So 25's first thing you have to do is convert your 25 centimeter cube into litres. So 25 centimeter cube is 25, because it's in litres, it's 0.025 litres. Okay. So to find the number of moles, the concentration is 0.1 times by the volume 0.025, and that gives you 0.0025 moles. So to find the mass, now the mass of 1 mole of potassium hydroxide is, quick calculation, potassium hydroxide 56. So the mass is, you have got 0.0025 moles times by 56. So you're going to need 0.14 grams. And there's your 5 marks. Pause the video and have a look if you're not sure. Next one, if we move on. The student realised that they needed a different solution to with a concentration, and the student added 5 grams of potassium hydroxide to 25 centimetre cube of water. What is the concentration of the solution they found? So pause the video here. Okay, let's have a look. So again, you need to convert the 25 centimetre cube into litres, which we've done earlier on. So it's 25 divided by 1,000, and we got 0.025 litres. Okay. So to find the mass, to find the concentration, so we have 5 grams. So concentration equals 5 grams divided by the volume. We get 200 grams per litre. And that's worth 3 marks. And then the final one, convert 15 centimetres into litres. You can pause the video here, 1 mark each. Okay, the final one, 15 centimetre cubed into litres. You should get 0.015. Next one, 0.4 litres is 400 centimetre cube. And the final one, 15 kilograms, is 15,000 grams. And that is a quick revision of our lesson on topic 3 AQA. Okay?